This is number 27 from the Newton's Laws practice. Again, it's an elevator problem. This time though, there's no guessing about which force is greater. This time I know that the normal force is greater than the weight because I'm told that the person is accelerating upward. And this time it is a normal force because it's a person on a surface. So the normal force is greater than the weight. And I'll just label the weight right now. It's going to be a quick calculation. For number 27, I'm going to do 70 times 9.8. I'm just plugging into force weight equals mg, and it's 686. So I'll just write that right here. Force weight is equal to mg, which is 686 newtons. It's just good to know that and just not mix that up with the mass. So here's the key step. Sigma F equals ma. And stop and ask yourself, do I understand what sigma F means? It means look at all the forces. In this case, I just kind of obey the diagram now. Just look at the diagram. I'm not going to add force normal plus force weight. What am I going to do with force normal and force weight? Subtract them. So I just write down force normal minus force weight equals ma. And for some reason people neglect to write this equals ma part. I think they're just so focused on these two forces that they forget. Just keep following the equation. Keep the ma. And it's also abstract. People don't know what these numbers are, so they don't like writing them down. People don't like to write force normal and force weight. They want to put down a number. We don't have a number for that, so just get in this habit. So now I write down force normal minus 686 is equal to the mass, and this time it's a person, not the elevator, so it's 70 kilograms. And I'm told what the acceleration is, and since it's upward, I'll put 2.2. I'm just going to put a plus sign in front of that. Sorry, 2.3. Now I have an equation that I just have to solve for force normal. I just have to solve for that variable, and that's it. The 2.3, the question was just asked where the 2.3 come from. The problem actually tells you the acceleration is upward at 2.3. And Aaron, if it had said the acceleration is downward at 1.2, even though they don't put a negative, if you see the word downward acceleration, you would put a negative right here if they had said it was accelerating downward. And once you do that, it's easy. You just solve, do the algebra. So right now in my calculator, I know I'm just going to do this. I'm going to do this here, and then I'm going to just add the 686 to isolate the force normal, and then I'm done. 70 times 2.3 plus 686, and the normal force that you get is 847 newtons. And I'm going to pause it and take questions now. So the question that was just asked was really a general question about how do you know which force to subtract from which? And the answer is, I think the easiest way to do it is stick to the convention, up minus down. Just always do up minus down, and you can't go wrong. If you end up with a negative number, that simply means that you have a negative acceleration.